Hi guys, welcome to the today's session of design and analysis of algorithms. In this session, we are going to discuss about decrease and conquer algorithm design strategy, which belongs to module 7. In this module, we are going to discuss about decrease and conquer introduction, insertion sort, depth first search, breadth first search, and topological sorting. So as part of today's session, we are going to see the introduction to decrease and conquer algorithm design strategy. Coming to decrease and conquer strategy, decrease and conquer is a technique used to solve problems by reducing the size of the input data at each step. Here, the decrease and conquer is an algorithm design technique in which the problems can be solved by reducing the size of the input data at each step of the solution process. So this technique is very similar to divide and conquer, where the problem breaks down into smaller subproblems. But here the difference is that in decrease and conquer, the size of the input data is reduced at each and every step. It is a general algorithm design strategy based on exploiting the relationship between a solution to a given instance of a problem and a solution to a smaller instance of the same problem. So here the exploitation can be represented either in a top-down way or in a bottom-up way. The major variations of decrease and conquer are decrease by a constant, decrease by a constant factor. Usually we consider that constant factor as half. Variable sized decrease. Now we will see all these variations of decrease and conquer one by one. So first we are going to see decrease by a constant. So here in this variation, the size of an instance is reduced by the same constant on each iteration of the algorithm. Typically, this constant is equal to 1. Although we can use another constants for size reductions. Right. Here you can see the diagrammatical representation for this decrease by a constant. Here initially you have a problem of size n. You are going to in the first iteration you are going to divide the problem into subproblems of size n minus 1. So here your size is n. Here you have the size of the problem is n. Here you can reduce it by 1. So here you are taking the size of the problem as n minus 1. That is, you are subtracting 1 from that. That is, here you reduce the size of the problem, and here we are going to find the solution to that subproblem. And by finding the solutions, at the next step, you go for dividing the subproblem into n minus 2. Like that. So at every step, you are going to divide the problem by 1. And you are finding the solutions for those subproblems, and you are going to find the solution of given original problem. Right. So the applications that can be solved by using this decrease and conquer method, that is decrease by a constant, or insertion sort, graph traversal algorithms such as BFS and DFS, that is breadth first search and depth first search, topological sorting, and we can generate the permutations. We can use the same method for generating the combinations as well as for generating subsets, etc. These are all the different applications that what we can solve using this decrease and conquer variation. Now coming to the next second type of variation, decrease by a constant factor. So usually we consider that constant factor as half. So here this technique suggests reducing a problem instance by the same constant factor on each instance or on each iteration. In most applications, this constant factor is equal to 2. Reduction by a factor other than 2 is especially rare. So that is, here you can see your problem, initial problem size is n. In the first iteration, you have divided your problem by 2. That is, the size of your problem became n by 2. That is, you are dividing the problem size with a constant factor 2. Right. So in the next iteration, it is again divided with 2. That means the size of your problem becomes n by 4. In the next iteration, the size of your problem becomes n by 8. Like that, for different iterations, your problem size can be reduced by a constant factor. So, but in some cases, we can take that factor as 3 or that factor as 4 directly. Like that, we can take. But in rare cases, we can consider these type of factors. So, it is a efficient one. Decrease by a constant factor algorithms are very efficient, especially when factor is greater than 2. As in fake coin problems, etc. We can use that. So here you can see the diagrammatical representation for this, and the basic applications that we can solve by using these type of decrease and conquer variation or binary search, fake coin problems, Russian peasant multiplication, like that. These type of applications can be solved. Right. Coming to the next variation of decrease and conquer, variable size decrease. Variable size decrease. So in this variation, the size reduction pattern varies from one iteration of an algorithm to another iteration. So earlier you have seen decrease by a constant means in each iteration, your problem size is decreased by a constant value. That is, if your initial problem is n minus 1, at first iteration, if it is decreased by 1, then in the second iteration, it is decreased by again 1. The third iteration, again it is decreased by 1. Like that, it will be decreased. So if your problem is n, in the first iteration, if it is decreased by 2, then it becomes n minus 2 becomes the size of the problem. And in the next iteration, the size becomes n minus 4. In the next iteration, the size becomes n minus 6. Like that, it will be presented. In case of decrease by a constant factor, so if your initial problem size is n, your problem size in the next iteration becomes n by 2, and in the next iteration becomes n by 4, and in the next iteration becomes n by 5, and so on. So if your problem is decreased by a factor 3, in the next iteration it becomes n by 6, in the next iteration it becomes n by 9, and so on. Like that, n by 18, like that it will be presented. Right. So, but in case of variable size decrease, so here, here this is by a factor, decrease by a factor. But in case of variable size decrease, here from one iteration to another iteration, the size of reduction pattern changes. So the best example for that is calculating the GCD. So the second argument value is always smaller on the right hand side than on the left hand side. So it decreases neither by a constant nor by a constant factor, right? So the best examples for this a variable sized decrease are computing the median in selection problem, interpolation search, and Euclid's algorithm. So I hope that you all understand the three variations of the decrease and conquer method: decrease by constant, decrease by a factor, and variable size decrease. And coming to the advantages and disadvantages of decrease and conquer, the main advantages of decrease and conquer method are its simplicity, and we can develop efficient algorithms, and it is problem specific. So coming to the simplicity, decrease and conquer is often simpler to implement compared to other techniques like dynamic programming and divide and conquer. And that is, we can easily understood the decrease and conquer algorithm design strategy when compared to the the dynamic programming and other algorithmic design techniques. And coming to efficient algorithms, this technique often leads to efficient algorithms as the size of the input data is reduced at each iteration. Since the size of the problem is reduced at each iteration, it automatically reduces the time complexity and space complexity. And coming to problem specific, this technique is well suited for specific problems where it is easier to solve the smaller version of the problem easily. So we already seen the applications such as insertion sort, BFS, DFS, all these problems. So for that type of problems, this model is well suited. Coming to disadvantages of decrease and conquer method, the two main disadvantages are problem specific and implementation complexity. So this technique may not be suitable for all the problems. It may be suitable only for some specific problems. And implementation complexity. This technique can be more complex to implement when compared to other techniques such as divide and conquer. And that is, it requires a more careful planning for the implementation of this. So I hope that you all understood the general method of decrease and conquer and the different variations of decrease and conquer, as well as the advantages and disadvantages of decrease and conquer. In the next sessions, we are going to see the applications of these decrease and conquer. Thank you for listening. Thank you.